Hello, my name is Oliphant, and I'm a mechanical engineering major here at Oregon State University. And today I will be discussing the research focused on transferability of virtual tasks to physical pruning environments. This is the research I've taken part in this summer, and I do hope to continue this through the school year. A little bit of what pruning is, just for those who aren't aware. Pruning is a selective removal of certain parts of the plant, such as branches, buds, or roots. This is a very selective process. It differs from plant to plant on how you prune said plant, so there's a lot of variety in that sense. Pruning is an incredibly labor-intensive process. It's very time-consuming. It ranges from mid-November to mid-April, and it's one of the second most expensive orchard tasks after harvesting. Now, with this, and knowing that it is incredibly labor-intensive, super time-consuming, it is also a very difficult task to complete. It does take around 1 to 2 seasons to fully learn and understand the heuristics for each orchard, as it does differ. So what the research we're doing is looking at how can we design a training tool to speed up this process. Now, the big question, of course, is designing this training tool. We want to design this training tool to increase pruning efficiency in the field, and with this, we do hope to design a virtual interface that can be used as that training tool. Now, like I've mentioned earlier, pruning is a visual-spatial task. The behavior relies on what the tree looks like. In this image, you can see two different types of branches with the various distances on how you would prune the tree. The problem that we're looking at for our interface and the visual and the virtual aspect of it is how can we transfer the virtual tools of the virtual environment to a physical environment with the most realistic possibilities. There's been a lot of research to go into visual spatial understanding. Past work in both VR and AR have attempted to address these problems. They've looked at distance and spatial awareness while in a VR headset or in a more virtual environment, but none of these have considered them in conjunction with the visual spatial task of pruning. They've never addressed it in an agricultural sense, and so that's what our research is going to address. So our solution is to conduct a study to determine how to mitigate problems in visual spatial pruning tasks to help in transferability between virtual or digital and real trees. With this study, we will be designing and building an interface and a visual proxy, which is a lot of what I've been doing this summer for my research. So talking a little bit about what I've been doing this summer, I've gotten the chance to design an interface. We've used Python for the interface itself. We've used LPy to grow the digital trees to make them look as realistic to orchards as possible. And we've used Blender to make the graphics look as realistic as possible. With this, we've also used the socioeconomic inclusivity magnifier, which basically looks at different socioeconomic backgrounds and different backgrounds in people's ability to understand technology, and applied that to our interface to make sure that it's as usable as humanly possible. This is an example of what the interface looked like in a Google Slides. So we went through many different iterations in a Google slide to make sure that our interface was as user-friendly as possible. So this is how we address that inclusivity aspect. And now this is what the interface looks like currently. Where this image is where the LPy trees will be, so where we grow those digital trees, and you'll see an example of that in just a second. With this interface, as we briefly mentioned earlier, there also will be a visual proxy. This is just another aspect of that to address that transferability, and this is just something that people can interact with. We're using real branches from a grape tree in the area, and we're using 3D printed brackets to be able to attach all the branches as necessary. Again, we want this to look as realistic to an orchard as possible, so we're using a V-trellis system and example, but currently this picture is a CAD diagram of what I have developed so far. For running the study, we will have two groups. So one group will look at just the physical tree, or that visual proxy that you see there in the middle, and then they'll go straight to the interface. Now the second group will also see that visual proxy, but they will also see that visual proxy in the interface as well. The difference, and the big difference between these two groups, is that there will be one group will be able to see the visual proxy within the interface and one will not. This is just an example of what it would look like inside the interface. This is an example of that LPI tree, kind of how they would see it. If that is what the visual proxy looked like, that's what they would see. Now, our transferability aspect, of course, is what the big question that we're trying to answer here. So using the visual proxy and the interface, our goal is to create as a realistic environment as possible. With this, we have not run the study. We are still in that building stage of both the interface and the visual proxy, which is what I've been doing this summer. But the next steps and the next goal is to be able to run that study and be able to analyze, was the visual proxy in the interface realistic enough, and were skills able to be transferred from that interface and visual proxy to a real life orchard and a pruning environment. I just want to hit this really hard, that the pruning is an incredibly labor-intensive task. It does take 1 to 2 seasons to fully understand, but using this interface and the visual proxy, we hope to replicate a realistic environment to be able to decrease that amount of time from 1 to 2 seasons to maybe 1 season, or maybe even half a season, for pruners to be able to fully understand those pruning heuristics for each orchard. Now, with all of that being said, I have learned a lot on this internship, and I'm incredibly happy to have gone through it. I'm really excited to be able to be a part of the ongoing research and preparing for that study, hopefully to come. I know that I have learned a lot, but I also know that I have a lot more to learn, and I'm incredibly excited. We will be working through the coming months, and we do hope to run that study by the end of September. Just want to do a quick acknowledgement. Thank you to AgAid, thank you to my mentor, Deanna Flynn, and then of course thank you to Dr. Cindy Grimm as well, and of course the Oregon State University. So again, thank you. My name is Lily Oliphant. My email is right there. If you have any questions, you can definitely just send me an email. I will answer right away as fast as possible. And then there's also that GitHub if you want to look at any of the interface code that we're working on as well. So thank you.